Hello students, this is Mr. Maat with another physics lesson. In this lesson we will focus on the gravitational field strength. After that we will talk about the homework questions and we'll go through all the questions and show you the correct answers. There's also a bit of homework for next lesson and that is actually pretty easy. You just need to check those answers from lesson number 2.10.11 again and make sure that you understand everything. Okay. Last lesson we talked about the gravitational field strength and I explained to you that it's actually an acceleration caused by the planet you're standing on. If the planet's bigger, there's a bigger gravity force pulling on you, so the acceleration will be bigger. The gravitational field strength will be bigger. Well, if we take a closer look to the gravitational force working on objects, I made a drawing and you see two objects. And mass number 1 is over here on the left and mass number 2 is on the right. Well, the stranger thing about objects in the whole universe is they attract each other. So right now the Earth is pulling me down, so my mass is actually attracted to, well, the Earth I'm standing on. Well, that also works in all, with small objects or larger objects. It's all gravity force working on you. Well, if you have two objects and the mass is the same, well, then the gravity force working on you caused by mass number 2, well, of course, is going to be equal in size as the gravity force caused by mass number 1 pulling on mass number 2. So the first rule that you need to know is this, that equal masses have the same gravitational force. So if the mass is the same, the gravity force pulling on it is exactly the same. Well, now take this situation. In this situation you see that mass number 1 is larger than mass number 2. Well, if that is the case, then the gravity force pulling on mass number 1 created by mass number 2 is going to be smaller in magnitude than the force of gravity caused by mass number 1. So mass number 1 pulls an object with a smaller mass, well, with a bigger force towards the center of that mass. So the second rule that you need to know is this: the greater the mass, the stronger the gravitational force will be. And then we have the third situation. In the third situation I have again the same masses as the first example, and in this situation the masses are just closer together. The masses are the same, but when masses come closer together, then the gravity force will be bigger again. Because they are equal in size, that means that the gravity force is also equal. But take a good look. If you compare the situation over here, the forces are smaller than the forces over here. So getting the masses closer together, well, will cause a bigger gravity force. So that is the third rule. The third rule is like this. The closer the masses, the stronger the gravitational forces. So you just need to remember those three rules because they are very important if you deal with gravity force. Well, last lesson I already showed you this slide, but it's a very important slide and I'll repeat it again. If you take a look at the general formula that is created by Mr. Newton, Newton's second law, it tells you that the force is equal to the mass multiplied by the acceleration. Well, this is the formula for every force around you. So also for gravity force, but for instance also impact force or the normal force. You can always calculate forces in this way. But because we're working with gravity all the time, we created a special formula for gravity force. It looks almost the same. We still have that capital F, but now there is a G next to it. And we replace the acceleration, the symbol for gravitational field strength. Last lesson I already told you that the gravitational field strength is actually the acceleration caused to the mass where you're standing on. So this is the acceleration and this is the acceleration due to gravity. Make sure that you're able to use both formulas in the upcoming test. So this is another picture I want to show you, and it shows you that wherever you are in the universe, there is always gravity pulling on you. It can be less, but there is always gravity. So take a good look. Those lines, they represent the gravitational field strength on a certain location. And you see if you're closer to the Earth, the gravitational field strengths will come closer together. And it tells you that the gravitational field strength is actually increasing. So if you go away from the center of the Earth, you see that the distance between those lines is getting bigger. And it tells you that the gravitational field strength is getting less. So getting away from the Earth will reduce the gravity force pulling on you caused by the Earth. But if you're closer to the Moon, then of course the Moon will start pulling on you. So there is always gravity working on you wherever you are in the universe. Okay, so far the theory. I want to focus on the homework questions that you did online. This is the first question. What is the weight of the following masses on Earth? And there are 3 masses given and it works every time the same way. So I'm going to show you the first one in detail and then I will skip to the B and C as well. So first I write down all the things that are given. Well, we're talking about the masses on Earth. So the gravitational field strength is 9.81 or it is 10, whatever you want, whatever you prefer. The weight of the gravitational field, the gravitational force is my question mark. This is the standard formula to use. The gravitational force is the mass multiplied by the gravitational field strength. If you fill that in, you get an outcome of approximately 20 newtons. Make sure you write it in standard form. This was the outcome question A. Here are the outcomes to question B and C. And you see I do it every time in rollback style. You should do that yourself as well. Question number 2. What is the weight of a 6 kilogram object on the surface of Mars? Well, remember that the weight is not the same as the mass. The mass is not going to change. It's 6 kilogram here on Earth, it's 6 kilogram on Mars. That doesn't matter. The mass is not going to change, the amount of atoms. What is going to change is the weight, the gravity force pulling on you. So the first thing that you should know is what is the gravitational field strength on Mars? Well, the gravitational field strength on Mars is 1/3 of that one here on Earth, so you just divide it by 3. Well, what is the weight on Mars? That is my question mark, so Fg on Mars is my question mark. I rewrote the standard formula a bit because it's on Mars. Fill it in and you get an outcome of approximately 2.0 times 10 to the power of 1 Newton. Question 3. It is planned to bring samples of Mars rocks back to the Earth. If 50 kilogram samples were collected by a space robot, what would be the weight of the rocks on Mars and on Earth? Well, same situation. You need to know the gravitational field strength on Mars. Well, that is 1/3, so 3.3 Newton per kilogram. Then I fill it in the standard formula and you get this result. If you compare this with the result here on Earth the gravitational field strength is 9.81, so you just fill it in and you see that the outcome is going to be bigger. So the planet Earth has more mass than the planet Mars. Okay, question 4. The Moon's gravitational field strength is 1/6 of that on Earth. What would be the weight of a kilogram object on the Moon? Well, if you know it's 1/6, then you just divide it by 6. So the gravitational field strength divided by 6 will give me 1.635 Newton per kilogram. I want to know what is the gravitational force on the Moon. So here's my formula. Again, you fill it in and you get an outcome of 1.6 times 10 to the power of 0 Newton. Question 5. A sample of a moon rock weighed 30 Newton on the Moon. What would be the weight when it was brought to the Earth? So take a good look. That 30 Newton is actually the gravitational force working on that object on the Moon. So you know that the gravitational field strength on the Moon is 1/6 of the gravitational field strength on the Earth. So that's an important thing to remember. So if the gravitational field strength is 1/6, then if you bring it to the Earth, it gets 6 times bigger. So the only thing that you need to do is take the weight multiplied by 6 and you get 180 Newton. What is the mass of the sample? Well, you can calculate the mass by taking the gravitational field strength, for instance, on Mars, and you know the gravity force working on that object on Mars. So in this case, you need to rewrite the formula a bit to calculate the mass. So you take the gravitational field strength, divide this side by the gravitational field strength. So do the same on the other side, and you get the formula mass is F divided by G. Fill it in and you get this outcome, 1.8 times 10 to the power of 1 kilogram. Question 6. The gravitational field strength on the moon is 1/6 that of the Earth. If you lived on the moon, how would the weight of some everyday objects such as your watch, school bag or sport shoes change? Well, the thing is this. The gravitational field strength on the moon is 1/6 of the gravitational field strength on Earth. That means that the moon is pulling you with a force of 6 times less on objects. So the weight of the objects would be less. The mass of the objects, of course, will still be the same. That is not going to change. Then we have question number 7. Assume that G is 10 Newton per kilogram and there is no air resistance. The rocks are falling near the Earth's surface. What is the weight of each rock? Well, the weight is of course the gravity force pulling on you. You have the mass that is given, so you can use the standard formula Fg is m times g. So you fill it in and you get the force working on both objects, 5 times 10 to the power of 1 and 1.0 times 10 to the power of 2 Newton. That is the gravity force working on it. Well, in question B, you're going to calculate the acceleration. Well, the acceleration was actually the same as the gravitational field strength. So in this case, well, you're going to calculate the acceleration. If you fill it in, you see that the outcome is, of course, that 10 meters per second squared. That is the same as a 10 Newton per kilogram. Don't get confused about the symbols, the units. Newton per kilogram is the same as meters per second squared. So in a question like, if this question was in the test, well, if you would just give me an answer that it should be the same as the gravitational field strength, the acceleration, it would be perfect. Then question C. Question C was of course 10. Then we have question 8. A spacecraft travels from Earth to Mars, where the gravitational field strength near the surface is 3.7. The spacecraft is carrying a probe which has a mass of 100 kilogram when measured on Earth. Question A. What is the probe's weight on Earth? B. What is the probe's mass in space? What is the probe's mass on Mars? What is the probe's weight on Mars? And when the probe is falling near the surface of Mars, what is the acceleration? Well, a couple of things. The mass is everywhere the same. So if you calculate it once for in space, well, you can have the same outcome for Mars. That is the same answer. The mass is not going to change. If you know the gravitational field strength on Mars, then you also know the acceleration on Mars, because that is the same. Okay, question 8. Here are the things that are given. I calculate Fg on Earth and that will give me an outcome of 1000 Newton. That is of course because 100 kilogram multiplied by 10, you get 100 Newton. If you calculate with 9.81, your outcome would be 981. Question B, the mass is everywhere the same, so in this case it's going to be that 100 kilograms. Question D, the mass is 100 kilogram. The gravitational field strength on Mars is given. We want to know the weight on Mars. So you fill in the formula, you get 370 Newton. E, if G on Mars is 3.7 Newton per kilogram, that means that the acceleration will be 3.7 meters per second squared. Well, a lot of information in this lesson, a lot of answers to questions. Please check your homework again for next lesson. If there are any questions, of course, you can contact me. If you like this video, please thumbs up and subscribe to my channel, of course. Thank you for watching.